Assalamualaikum and hello to our lecturer, Madam Miss Masnani binti Mohammed. We are from Group 1 in Section 1. We present of our title of project, which is our title SpO2 level monitoring. First of all, I want to introduce our team members. Firstly, me Muhammad Umar Ashraf bin Fakhr Arifin. Next, David Tiong Lungwi. And last one is Muhammad Akmal Hafiz bin Ishamuddin. So, to the introduction, I will pass to my team member to present to you.
Hi, a very good morning to Puan Mastani, our lecturer for this subject. And before I introduce myself, my name is David Tulungwe. My metric card is CE190146. So in this introduction, we are designing and simulating SpO2 level monitoring. So this SpO2 level monitoring measurement system is developed using seismography (PPG) sensor that is a non-invasive technology that use a light source and photodetector at the surface of skin to measure the volumetric variation of blood circulation. So this SpO2 level monitoring can measure oxygen level in blood. So next, however, this SpO2 level monitoring can monitor our oxygen saturation level intermittently, then can identify our condition early, and this can set a doctor help. Then, as we know, engineering and technology have made our current way of life very comfortable. So this next point is various type of healthy care wearable monitoring device has been introduced as a result of the arrival of healthy care wearable technology, and this device can be successfully used for immediate disease detection by collecting physiological data and prevention by providing the necessary treatment. The physiology data for the most of this device can be synchronized with laptop or smartphone, where it can be stored and listened using any software. So next, the oxygen saturation level is the most common medical data used to understand the patient condition. The next is our objective for this project. Firstly, we design a low cost of SpO2 measure monitoring. Then second point is use the microcontroller for faster signal processing and several other computation tasks. And third point is doing simulation in the Proteus environment. So our main objective of this project is to develop automated and low-cost oxygen saturation measurement system that will assist and support doctor in monitoring the patient condition. Next is theory part. So for this theory, this is SpO2 monitoring system. The block diagram that we are used show below. These are the that we use in this project. This is Arduino UART. This is the sensor. This is the LCD display. This is sensor PPG. So the system is contained Arduino microcontroller, a pulse oxygen sensor, a liquid crystal display LCD, and a DC power supply unit. We like to use Proteus to design the circuit, then implement the entry system measure precision level. The analog to digital converter value is converted to oxygen saturation level in percentage using the MX30100 sensor Arduino library function. So that's all for me. Thank you. So next part, I will pass to my friend. So thank you.
So I will continue of my part, which is my part is methodology. So in the methodology, I will present about the project flowchart, system flowchart, project block diagram, and measurement system. First of all, project flowchart, which is the investigation for this project begin, which I look at how blood pressure is measured in Malaysia now, and the most recent advancement in blood pressure monitoring system are studied and analyzed for use in this project. So this is our flowchart. Firstly, we start and we do the research on blood pressure measurement. research parameter required to monitor blood pressure measurement, and we continue to identification of problem in current blood pressure monitoring system technology. Then we go to the design a system for remote monitoring purpose. Then we go to the list of material and its procedure. Then go to the hardware construction by Arduino Nano and PPG sensor. Then the software program through MATLAB R2020E, and we go to the analyze the performance of system through IoT platform. And from the result, which is this accept or no. If no, the system will go back to the research on blood pressure measurement. If yes, discussion and conclusion, and lastly end of this flowchart. Then I will go to the system flowchart. So in the system flowchart, we start and go to the pass detector, which is the condition is yes, we go to the ADC by Arduino. If no, we return to start back. And if yes, we go to ADC by Arduino Nano. Continue to data is directed to MATLAB R2020 software. Then we go to the registration line in implement to obtain a systolic and diastolic pressure based on PTT. Then we go to the blood pressure measurement obtained. If yes, go to ThinkSpeak web and ThinkSpeak application, which is display the blood pressure reading. If no, we go back to the registration line in implemented to obtain a systolic and diastolic pressure based on PTT. Then we go to the project block diagram. So the hardware part of this project is the Arduino Nano microcontroller board and two PPG sensor. The first PPG sensor is put on the lock and close to the heart, and the second PPG sensor is placed on the index fingertip slightly further away from the heart. Then the pulse transit time PTT for both sensor is measured at this location. The MATLAB R2020A software was used in this study, while the ThinkSpeak web and ThinkSpeak version were employed as IoT platform. So the lastly is a measurement system, which is this system for measurement hypertensive patient blood pressure, which photolithosmography sensor is being properly built. So peak analysis of the PPG data was necessary for this produce. So thus two sensors are employed to measure the pulse transmit time value at time different body part, which is the ear lobe and fingertip. So the pulse sensor input was choose to get the photolithosmography PPG signal, since the sensor is already incorporated which an amplifier and normalized portion, which make data measurement easier because the signal from the human body is typically low in voltage frequency. So because of it capacity to carry out instruction repeatedly, the Arduino Nano microcontroller board was chosen. So that's all for my part. I will continue. I will pass to my next member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Marafis, CE180153. I'm from Group 1. Today I will explain about our project, our assignment project. We plan to create a SpO2 device, simulation of SpO2 device that will measure oxygen level in our patient blood. So we construct our full circuit in Proteus software to be simulated in this software. Unfortunately, in this Proteus software, we don't have any SpO2 sensor, so we just created a schematic diagram of the SpO2 sensor, and we connect it with the Arduino Nano, and then we connect it to LCD to show the result. But since we don't have any sensor, the device could not get the actual result to simulate and get the actual result. So in this simulation, we just show supposedly the SpO2 level we show in this LCD, but we couldn't get the result. So after we create a simulation in software, Pro2 software, we create it with hardware device to show the how the device work and the actual result in from our hardware device. So after that, we create a program according to our device, our hardware device. Or our device we use MX P0100 pulse oximeter. We connect it with our Arduino Nano and we upload the whole coding in our device. After that, we run our device and the result should show in our serial monitor. It will take a minute to initialize this hardware. As you can see, the device is already run. It will show the oximeter success. And after the finger detect, we will show the finger detect. And then we just need to put our fingertip and wait until the SpO2 result show. As we can see, the SpO2 result already show, and my SpO2 level in blood is at 95% or 94%. The device is not so accurate, but our device already show that our hardware device already work and it can obtain data from our sensor. Thank you.
Assalamualaikum. I will explain about our hardware device, how our hardware function. First, we need to upload our coding that we create in Arduino IDE application to our hardware device. After we upload it, we just need to connect our board with our device, our software, and then we just need to turn on the serial monitor to obtain the result from our device. After we turn on our device and connect with serial monitor, we should see our output. Okay, after we connect our device with Arduino IDE, we should see this output in serial output after we place our finger at our sensor. And the result should be on the serial output. The normal SpO2 is about 96 to 100%.
So hi, in this conclusion of project, we have designed, simulated and implement this simple and low cost pulse oxygen saturation level measuring device using a microcontroller and a sensor. So this project system is easily to use and no medical personnel is need to measure the oxygen level of a patient. So this means the patient can easily measure and monitor his oxygen level and send the data for taking advice or treatment from any remote place without going to the hospital or medical clinic. So lastly, we have also have main goal to this project where we can create a simple, portable and cost-effective solution for the pulse oxygen saturation level measurement. So that's all for me. Thank you.